Welcome, everybody. Very nice of you to join me. There are so many nice sessions to choose from, and you chose mine, so I'm honored. Thank you for that. My name is Bouke NIJHUIS. I'm the CTO at a company called Sync ICT, and yes, that's 5 in French. You can easily reach me on Twitter on the handle that is currently on the screen. And the topic of today will be improving your skills with the debugger. I have a few topics I would like to talk about today. And the first one is breakpoints. I assume that everybody knows that a breakpoint pauses the execution of your program. But there is more to breakpoints, and I'm going to show you what's more. Secondly, I will talk about stepping operations. Again, I assume everybody knows about the basic stepping operations, but I would like to talk about the advanced ones. The third topic will be evaluating expressions. So while debugging, you see the values of the variables, but I would like to go one step further. I would like to show you the outcome of expressions. The former last topic will be hot code swapping. I'm going to show you how you can change code in a running program without restarting it. And the last topic will be remote debugging. So normally when you're debugging a program that is started from your IDE, but it doesn't have to be the case. It can also be started elsewhere. So I'm not only going to talk about those topics, I'm also going to show them to you. This is a live coding session. Maybe the slides already gave this away. So we need a piece of code that we can debug. So I created a little program called Hello World. Maybe you heard of it before? Just to be sure, I'm going to demo it to you. If you run the code, it prints Hello World to the console. Oh, sorry. Like a proper Hello World program should. But I also added a little twist. If you provide a parameter, in this case my first name Bouke, it will print Hello Bouke instead of Hello World. So those are the two features of this fantastic program. Let's have a look at the code. So we have a Hello World class that contains one field called default value. It is a string containing the word world. Then we have the main method, and the first thing it does, it calls a method called createMessage, which is down here, and it passes the command line arguments. If we go to createMessage, it has one variable called name, which default to the default value, world, and then we check if there are any input arguments. If this is the case, we update the value of the name variable with the first input argument. Then we use a string.format to create a string that always starts with hello, then the value of the name variable, and it will always end with an exclamation mark. The string is returned and put in the message variable. And the last thing we do, we print the message variable to the console. So no rocket science here, but we don't need rocket science to show off cool features of the debugger. So one more last thing before we dive into the first topic, and how do you actually debug in IntelliJ? Now that part's pretty simple. The first thing you do, you click in the gutter. That's the area next to the line numbers. If you do that, you get this nice red dot. This is a breakpoint. The next thing you do, you go to the create triangle on top. You click there and you select the second option. If you do that, IntelliJ will compile the code for you, start up the program, start up the debugger, and attach the debugger. More about this process later in the presentation. So if we look at the screen, it looks pretty similar, at least the top part. There's one new thing in the top part, and that's the big blue bar. This is your current execution point. This is where the debugger currently is paused. If you look in the bottom part of the screen, on the left, you see the stack trace, and on the right, you see the variables and their values. So that's everything I wanted to tell you before I dive into the first topic. As I told you during the introduction, the first topic is breakpoints. I assume everybody knows that a breakpoint pauses the execution of a program. I'm not assuming anymore. You've just seen it. But I also told you that there is more to breakpoints. So let's start with right-clicking on a breakpoint. If you do that, you get a nice little pop-up with a few options. Let's discuss the options quickly. The first option is enabled. By default, breakpoints are enabled. And that's a nice default because we want our breakpoints to do something. But if you temporarily want to disable them, this is where you do it by unchecking the box. The second option is suspend. Again, by default, a breakpoint suspends or pauses the execution of your program. Again, I think this is a fine default, but there are situations in which you don't want a breakpoint to suspend or pause the execution of your program. I'm going to give you a demo in a few minutes. Then there are two radio buttons behind the suspend. The first one says all. That means it will suspend or pause all threads while hitting a breakpoint. If you select the thread option, it will only pause your current thread and not the other threads. I never use this option, but I can imagine if you're into thread programming, this is pretty useful. The first thing you can do is creating conditional breakpoints. A conditional breakpoint is a breakpoint that is only enabled whenever the condition is true. Let me give you a small example. If I type name equals, it's pretty hard to type if you're tall like me and it's a bit low, equals world. This one is true. So let me press done first. It's a bit hard to see, but over here there's a question mark. This question mark denotes it's a conditional breakpoint. So I'm going to restart the debugger, and because the condition is true, I expect the debugger to pause at line 15. And like you can see on the screen, it paused at line 15. But now let me change the condition to something that is untrue. So I'm going to fill in name equals Bouke, which is untrue or false. And if I restart the debugger now, you will see that the program finished with the execution, but it did not pause at line 15. That's because the condition is untrue. So when do you use a conditional breakpoint? You use a conditional breakpoint whenever you have a breakpoint that will be hit many, many times during the execution of your program, but you're only interested in specific cases. If you choose your condition right, it will only pause at those specific cases. So during the introduction, I told you there's more to breakpoints. And look at that. There it is. The more link. So let's click it. If you do that, you get a very big pop-up. And let me first clean up a little bit before I continue. Unfortunately, I only have 45 minutes, so I'm not going to discuss all the options in this screen. I'm going to focus on one small part. But before I'm going to do that, I would like to share something with you, because I have a reflex. The first thing I do, or used to do, whenever I start investigating a bug, is putting system out print lines in the code. And I don't think I'm the only one. Are there other people in the room who do the same? Quick raise of hands. I think about 40% of the people. I think this is a fine reflex, because it will give you information pretty quickly and you can start debugging. But there is a big disadvantage to doing this, because sometimes, and only sometimes, I forget to remove those print lines. Yeah. So I hear people laughing, so apparently other people have the same issue. So wouldn't it be nice if there was a way to prevent this? And as it turns out, there is a way to prevent this. And that way is using this thingy over here, evaluate and log. What I normally put in a print line, I nowadays put in here. So I type in stuff like this. This is what I normally would put in my print line. So before I'm going to press done, let's go back to the suspend. I'm trying to emulate the print line. I want this breakpoint to log something and to continue. I don't want it to pause. So I'm going to uncheck this box. So let's restart the debugger to see what happens. Also notice that the red dot over here in the gutter became a yellow dot. Yellow means it will not suspend or pause the execution of your program. So the program has run, and as you can see, there's something new over here. This is new. And this is caused by the breakpoint. I call this a logging breakpoint. So nowadays, when I start debugging something, I don't use print lines anymore, I use this, because it does not have the big disadvantage of ending up in PRs or even worse in production. But now I hear people thinking, this is really nice, Bouke, using this kind of a logging breakpoint, but creating one is a lot of work. First I have to click in the gutter, then I have to right click, then I have to click more, I have to uncheck suspend, I have to check evaluate and log, I have to fill in an expression. That is just too much work. And you're totally right, that is too much work. Let's see if we can do this a little bit faster. Luckily, IntelliJ helps us out here. If you select the thing that you want to log and shift click in the gutter, it creates a logging breakpoint for us. And this saves you a lot of clicks. Now I just have to press enter. And let's run it to see what happens. You see, it printed world. Now this is already pretty nice, but I'm a lazy developer. So I prefer not to use the touchpad or the mouse. So I want to do this keyboard only. Unfortunately, I could not find a way to do this keyboard only. So I decided to solve this problem by creating a plugin. So I created a little plugin. And if you select the thing that you want to log and press the right keys on the keyboard, it creates a logging breakpoint for you. And if I now run the program, you see, it prints the name of the variable, the contents of the variable, and it puts it between square brackets. And now I'm happy, because this is so much better than using print lines. I will publish the code of the plugin after this presentation. Actually, I even wrote a blog about it. I will post that as well on Twitter. So you can use this in your projects as well. So 2 more little things about breakpoints I did not know before I started investigating for this presentation. First of all, did you know that you can drag and drop breakpoints? I did not. And this is pretty cool if you have a complex breakpoint, because in the past I would just delete a breakpoint and create a new breakpoint. But if you have a breakpoint that's non-suspending, has logging conditions and all those difficult stuff, then this is far faster than recreating it. Another thing I sometimes accidentally do is left-click instead of right-click. Ah, damn, breakpoint's gone. If you do Shift-Shift, which is search everywhere in IntelliJ, the best invention since sliced bread in IntelliJ, you type in restore breakpoint or part of it, you press enter, it brings the breakpoint back for you. So you don't have to cry anymore whenever you accidentally click on a breakpoint. And that's everything I wanted to tell you about breakpoints right now. Let's go to the next topic, stepping operations. I would like to tell you about the advanced stepping operations, but before I can do that, I first have to talk about the basic ones, because the advanced ones build upon the basic ones. There are 4 basic stepping operations. And the first one is called step over. And it does what it says on the can. The button is over here, you can use this button or press the appropriate shortcut key, F8 on my machine. But if you click it, it will go to the next line. So it steps over the current line and goes to the next line. Let me demo that to you. Wow, it works. Then the next one is called step into. And step into works whenever you have a line that contains a method call. Now currently, the debugger is paused at line 8, which contains a method call to the create message method. If you click step into, it will go inside the create message method, like it just did. Then the third one is step out. Step out is the opposite of step into. So it will execute the method and then go back to the caller. So if I click it, it will execute create message and it goes back to line 8. Interesting point. The screen looks exactly the same as 30 seconds ago, but now we are in a point in time after we executed create message. And 30 seconds ago, we were in a point in time before we executed create message. So the big blue bar is an indication. It doesn't exactly specify where you are in the code, something to remember. I'll come back to this later in the presentation. And the third one is called run to cursor. So what does that one do? It will start execute the code until it will hit the cursor. So if you click over here, it runs code till it hits the line with the cursor. So those 4 stepping operations save you a lot of breakpoint creation. So let's go to the advanced ones. So the first 3 are force stepping operations. So I just told you, if you use step over, it goes to the next line. And that is true unless there are breakpoints in between. So if I would click step over, it would execute the create message method and then go to line 9. But now, step over wants to go to the next line. But now it finds a breakpoint in between the current line and the next line. If I now click step over, it doesn't pause at line 9, but at line 15. And that's because there is a breakpoint between line 8 and line 9, because line 8 will execute the create message method. So if you do not want this behavior, there is something called force step over, and I can never remember the shortcut. So I do it like this. And if you do that, it goes to the next line. It will ignore the breakpoints in between. Force step over. There's something similar with run to cursor. You can also use force run to cursor. So normally run to cursor runs until it hits the line where the cursor is, unless there are breakpoints in between. If that is the case, if you do want to skip those breakpoints in between, use force run to cursor. I'm not going to demo it because it's pretty similar. The third stepping operation, the third force stepping operation, is something different, and that is force step into. Let me clean up a little bit before I demo it to you. So I just told you step into can be used whenever there is a method call on the line, on the current line. Now on the current line, line 9, there's a method call to the print line message. But if I do step into, it does not step into print line. That is because by default, step into only goes into your own methods. It does not go into third-party methods. So if you want to go into third-party methods, you have to use something that is called force step into. And if you do that, it goes inside third-party methods, in this case, the print line. This is pretty useful whenever the bug is not in your code, but in a third-party library, like we mostly think, right? Who creates bugs in their own codes. So the next advanced stepping operator is the smart step into. But before I can demo that one, I have to rewrite the code a little bit. So what I'm going to do, I'm going to inline the message variable. What does that mean? It means that this piece of code goes over here. Now the easiest way to do that is to let IntelliJ do that for me. Oh. So what did just happen? I removed a variable that's not really necessary for the execution of the program. I removed an intermediate step that could be removed. So the outcome of the program is exactly the same. But this enables me to show smart step into. I just told you, whenever there is one method call on the line, you can use step into. But what if there are two? So smart step into kicks into gear whenever you have two or more method calls on one line. Currently, we have a call to create message and to print line on the same line. So smart step into is enabled by default in IntelliJ. So if you use the normal step into, it's smart enough to use the smart step into. No pun intended. So I click the button, and now I have two pinkish boxes. And with the arrow key, I can select one of the two. And if you press enter, it goes inside the method that you just selected. In the past, it worked from the right to the left, so you first had to do all the method calls on the right before you could go to the method call on the left. Nowadays, we have smart step into. Saves you a lot of clicks. Let's continue to the last advanced stepping operation, and my favorite stepping operation, and that is dropping frames. So up till now, all the stepping operators I've shown to you are going forward in time. So let me explain that. We have the starting point of our application, we have the termination point of our application, and step into, step over, run to cursor, they're all going towards the termination point of your application. So they're going forward in time. As it turns out, there is also one operation that goes backwards in time that enables you to time travel. And that one is called dropping frames. So the first logical question we should answer, what is a frame? Very good question. To explain that, we first have to talk about stack traces. So I assume everybody knows that stack traces are built up out of method calls. So we have the main method, calls another method, calls another method, calls another method, and this is how we build up stack traces. Another name for an item in a stack trace is a frame. So if you drop a frame, you remove something from the stack trace. And it's called a stack trace. So if you remove something, you remove it from the top. It's a stack. So let me show you how that works. Currently, we have two items in a stack trace down here, the main method and the create message method. If I remove the top item of the stack trace, it will go back to the main method. It will go back to the caller. And let me show it to you. If you do this, nowadays it's called reset frame, but in the past it was called dropping frames. But if you do that, bam, the blue bar went back from line, let's say 14, back to 8. Interesting thing is that we're now in a point of time before we call create message. While 30 seconds ago, we were inside create message. So debugging-wise, we've been time traveling. We went back in time. And this mechanism is really useful whenever you are debugging somewhere near the termination point of your application, but you need to be somewhere at the beginning. In the past, I would put a breakpoint over here, restart the application and start over. Nowadays, I just drop a few frames. Also, a word of warning, this time traveling effect only works within the context of the JVM. So if you do a database transaction and then you drop a frame to go back in time, it will not roll back the database transaction. It only works within the context of the JVM. It becomes even more powerful if you combine this technique with remote debugging and hot code swapping. So let's go to the next topic. The next topic is evaluating expressions. The fastest way I know in IntelliJ to evaluate an expression is called quick evaluate expression. I try to restart the debugger, but nothing happens. So let me try again. Yeah, there we are. So the expression that I would like to debug is this one, string format. I want to know what the outcome of the string.format is. So the quickest way I know in IntelliJ to do that is quick evaluate expression. On a Mac, you hold the Option key. If you're on a Windows or on a Linux machine, you hold the Alt key. And you hover with your mouse over the expression. You see, it becomes blue and underlined. Then you left click, and there's a little pop-up you probably cannot read. But now you can see the outcome of this expression is hello world. That's cool. This is the quickest way I know. The name quick evaluate expression implies that there also is a normal evaluate expression. Let's demo that one. So the first thing I do, I select the thing that I would like to evaluate. And I click on this button over here, or press the appropriate shortcut key, of course. And if you do that, you get a pop-up. Then you press enter, and it evaluates the expression for you. This is a bit slower, but there is one big advantage to this way, because now we can play with the expression. I can just change the name variable into my first name as a string, press enter, and it re-evaluates the expression. And this is really powerful, because sometimes you know exactly where your bug is, but you don't know how to fix it. Let me give you a little demo. Let's say I want to print hello, then a dot or a comma, I don't care, and then exactly 2 zeros, right? So I'm a lazy developer. I could read the documentation of string.format, but who does that? We just try till it works, right? So the first thing I would try is just this. I would press enter, and okay, I have 1 0. Almost there, it's not good enough. I want 2 zeros, exactly 2 zeros. So I know I have to play with this S, right? This S is for string. So what I'm going to do, I'm going to change this till it works. So I can try decimal, illegal format conversion exception. That's not right. I think the D is for day, so maybe that's why. I can try the N for number. Looks nice, but I want 2 decimals, so not the desired outcome. Yeah, let me think. Oh, now I remember something. Maybe I should give a number in the right format, and then the formatter is smart enough to apply this format. Let's see what happens. Unknown format conversion exception. It's not working well. I remember. Maybe I should put an F here. Hey, the background went from brown to white. That's mostly a good thing. Oh, this is nice. So I have 11 zeros, but now I know how to fix this. 2 zeros at the end. This is the desired outcome. So did you notice what just happened? I tried about 5 fixes in under a minute. And this is the power of evaluate expression. Also a word of warning, because playing with expressions can be dangerous. Let's say I do this. So I've been playing with expressions, but now I close the screen and nothing bad happened, right? So let me finish the execution of the program. The program says, sorry, I hit the wrong key. Not sure what happened. This is annoying. What was I doing? Oh yeah, the output. I need the output. Does somebody know how I get the output back? No, it doesn't matter. I just rerun it. Now the output was hello Fritz, but there is no Fritz in the code. There is no Fritz in the command line arguments. So while playing with evaluate expression, I changed the global state of my program and therefore the outcome of my program. And that is the warning. So when you play with evaluate expression, please be aware you could be changing things that could be changing the outcome of your program. Okay, one last topic within the evaluate expression chapter. We're gonna evaluate a very special expression, namely a stream. I prepared a little stream and I'm gonna do a few things. First, I'm gonna try to explain in words what it does. Then I'm gonna explain the code. And then I'm gonna show you how you can debug a stream. And I'm already gonna tell you cannot do this with conventional debugging methods. It just does not work. Luckily, there's a solution and I'm gonna show you the solution. So this is a simple right shifting algorithm. What does that mean? If the input is A, the output is B. So what I do is I take the characters in a string and I move them one position to the right alphabet-wise. So A becomes B. ABC becomes BCD. So how does that work when we look at the code? We take a string and we apply the GARS operator. This one takes every character in the string and transforms it into an ASCII code. The second one will increase all the ASCII codes by 1. Third one will transform the increased ASCII codes back to strings, single character strings. And the last one will join the small strings into one big string again. So explaining this was not really hard, but also not really simple. So wouldn't it be nice if there was a way that we could see the values flowing through the stream to get really insight of what's happening inside the stream? Now, like I said before, this is not possible with conventional debugging methods. You can put a breakpoint over here and then you can step through the code, but it will not show you what's happening inside the stream. But luckily, IntelliJ helps us out. Whenever the debugger pauses on the line containing a stream, this button over here becomes available. This pop-up contains 4 tabs corresponding to the 4 operations in the stream. Remember, the first one was transforming every character in the string to an ASCII code. And look over here, 5 ASCII codes. The second one was increasing all the ASCII codes by 1. The numbers on the right are 1 higher than the numbers on the left. The third operation was transforming the increased ASCII codes back into single character strings. On the right, single character strings. On the left, increased ASCII codes. And lastly, we would join all the small strings into one big string again. Look over here, one big string with an unpronounceable word in there. And this is the power of the stream debugger. So the next time, whenever you have to debug a stream, use this fantastic tool. This was just a simple example. Imagine if you have a complex stream, how powerful this tool is. Okay, how much time left? 16 minutes, nice. Let's go to the next topic, hot code swapping. First gonna create some room. Okay, hot code swapping. During the introduction, I told you that hot code swapping is changing code in a running program without restarting it. So let me show you how that works. I put a breakpoint over here and it says what? Okay, let me restart the debugger. Let's see what happens. Yeah, so the debugger is paused at line 8. The thing that I want to change is the hello. I'm going to change it into bonjour. Did I pronounce that correctly? Yes. Okay, so the first thing that you have to do something called reload change classes. So IntelliJ will recompile the class, put it in the JVM, and then the new class is there. So I used shift, search everywhere, and then the first letters of reload compiled classes. If you do that, it will compile the class, put it in the JVM, and it will show with a little green balloon that it's done. If you finish the execution of the program, you see, it says bonjour world. So I changed code in a running program without restarting it, which is pretty powerful. But there are limitations. And the limitation that annoys me the most is the following. You are not allowed to change code in your current method or frame. So the reason that I put the breakpoint over here in the main method, so I could make changes in the create message method. Let me show you what happens if I would have put the breakpoint over here. Oh wow, I dragged and dropped it and it went away. That's interesting. Lovely live demos. So let me restart the debugger. Okay, now the breakpoint is in the create message method. If I change bonjour into guten Tag, which is the German formal version of hello, I reload change classes again. We wait for the green balloon, and I finish the execution of the program. It still says bonjour, but it says guten Tag over here. And that's because you're not allowed to change code in your current method or frame. And this is pretty annoying, because normally when I'm debugging, I'm stepping through the code until I find the issue. And then if I find the issue, in most cases, I want to change something around that spot where I'm currently at. So probably I want to change something in my current method or frame. So let's see if we can find a workaround. There is a workaround, of course. And the workaround, of course, is dropping frames. So what I'm going to do, I'm going to change guten Tag into goedendag, which is the Dutch formal version of hello. Any Dutch-speaking people in the room? Only one? Okay. So I'm gonna reload change classes again. And now, this is the trick. What I'm gonna do, I'm gonna drop the frame. If you do that, the current method is the main method. I changed things in the create message method. So I did not change things in my current method. And this is how you circumvent this limitation of hot code swapping. So you see, goedendag world. I use hot code swapping whenever I have an issue that I cannot reproduce with a unit test. So how do I normally work? I get an issue. I write a unit test. I run the unit test. It's red because I did not fix the issue. I write a fix, and if the unit test becomes green, in most cases, I fixed the issue. Sometimes I have issues that I cannot reproduce with unit tests. So how do I work in that case? I create a fix. I restart the program. I do manual actions because I don't have a unit test. And then I see if the fix works. If it doesn't work, I start over. So new fix, restart the program, manual actions. Nowadays, I do it in the following way. I write a fix. I use hot code swapping to implement the fix. Then I drop a frame to go back in time and then step forward again to see if the fix works. Why is this faster? I think this approach is already faster than restarting and doing manual actions somewhere else. But the real big bonus is in the fact that you don't have to leave your IDE. You can hot swap your code in the IDE. You can drop frames and step forward again in your IDE. So you don't have to leave the IDE to do manual actions in a different program. So if I were you, I would use hot code swapping in combination with dropping frames. And that brings me to my last topic, remote debugging. This, what I just shown you, becomes even more powerful if you combine it with remote debugging. So during the introduction, I told you that in most cases, you debug programs that are started from your IDE. And this is true up till this point in the presentation. Everything I did up till now was debugging programs that are started from your IDE. But you can also debug programs that are started elsewhere. So what I'm going to do is I'm going to run a program in a terminal, and then I'm going to debug it from IntelliJ. So somewhere near the beginning of this presentation, I told you about the fact that IntelliJ compiles code, starts up your program, starts up the debugger, attaches the debugger. Now, if you look closely to the console, you see traces of this process. This line over here is from the debugger, and the debugger says, I'm connected to the target VM, the running program, at localhost and then some port number. So apparently, we have a program listening for a debugger and a debugger that attaches to that port. So let's focus on how do you make a program listen for a debugger. But before I can focus on that, I'm first going to show you how you instruct the debugger in IntelliJ to do remote debugging. So shift again, search everywhere, and I type in econf. So I want to change, edit, run configurations. Probably, I think people are familiar with the screen. If I press the plus or use Command N, I can create a new configuration. I type in remote, and the thing that I want is this one, remote JVM debug. That's the configuration we need for remote debugging. If I press enter, I get a new configuration. The first thing I do, I change the name. Let's call it Devoxx. Yeah, let's call it Devoxx. No, let's call it Devoxx Remote. And then here's some default configuration. By default, a remote JVM debug configuration wants to connect to a program that is listening on localhost 5005. And this is a fine default. So we leave it at that. But the big question is, how do you make your program listen for a debugger? Now that part is actually pretty simple. You copy this part, you go to the terminal, and you paste it in the right spot, which is over here. So notice that I put it in double quotes. If you don't use the double quotes, the shell will try to expand this asterisk. And we don't want that. We want the star to be there. If I press enter, something happens. The program runs, and this line is new. So apparently, adding those command line arguments did something. Our program started listening for a debugger. Unfortunately, the program is so fast, it finished executing before I could even attach a debugger. So we have to make one more little change. Somewhere in here it says suspend is yes, no, and it has to be suspend is yes. If you do that, and press enter again, the program starts up, starts waiting for a debugger, and pauses. So the program now is waiting for a debugger to attach itself. And once the debugger is attached, it will start running again. So let's attach a debugger. Yeah. Everything on this screen are instructions for the debugger. We did not start a debugger yet. It's only instructions. So now I want to start a debugger, but before I'm going to start a debugger, it would be useful if we had a breakpoint. Otherwise, the debugger doesn't pause. You know that now. So I use my favorite shortcut again, Shift, and I type in remote. Was it Devoxx remote? I think I called it Devoxx remote, right? Yeah, there it is. So this is the remote JVM debug configuration that we just made. And it says over here, if you want to debug, press enter. Let's do that. Hey, the debugger is attached to something, right? We're debugging something. That something has as input argument Bouke. Look over here. This one has also as input argument Bouke. So we're debugging the program on the terminal from IntelliJ. And I have 7 minutes left. Yeah, let's do a little bonus. Everything you can do while locally debugging, you can also do while remotely debugging. So let's change some code, just because we can. Okay, the informal version of hello in Dutch is hallo. Now I have to reload to change classes again. And remember, I'm changing code in my current method or frame, not allowed. But everybody knows the workaround now, drop a frame. Now if we finish the execution of the program, it says hallo Bouke. So I've combined remote debugging with hot code swapping with dropping frames. It doesn't get any more fancy in this presentation. So this is remote debugging. Debugging a program that is not started from your IDE. But now I hear people thinking, this is really nice, Bouke, but where's the remote part? Everything is running locally on your Mac. You're right, everything is running locally on my Mac. That's easier for me to demo. If you really want to debug a remote server, there are two conditions. And then let me first show you the screen. So this is the remote JVM debug configuration that we made. It says localhost here, but of course you can put a remote host or a remote IP address in here. And there are two conditions for real remote debugging. First of all, the remote JVM should be open for remote debugging. Now that part is easy. Use those command line arguments like I just did in the terminal. And the second part is the debugger in your IDE should be able to reach the remote JVM, so networking-wise. There shouldn't be any firewalls in between. And if both conditions are true, you can do real remote debugging. So when do I use remote debugging? I use it whenever I have an issue that I cannot reproduce locally. So sometimes I have issues that are only occurring on specific instances or specific servers. And if that's the case, I use remote debugging to connect to the machine to get more information. But more importantly, I can also use remote debugging to try out fixes. Because what you can do, you can remote debug to connect. You can use hot code swapping to bring the fix there, and you can use dropping frames and stepping forward to test this fix. And this is really powerful, because if I would not use this technique, I would use the old way. So I would create a fix, create a release, deploy the release, code to the machine, do manual interaction, because it only happens over there. I cannot reproduce it with a unit test. This process will take, if you're lucky, 15 minutes, but if you're unlucky, more than 15 minutes. If you use remote debugging in combination with hot code swapping and dropping frames, you can test fixes in under a minute. And this is the power if you combine all those techniques. Also a word of warning. Remote debugging can be pretty dangerous. Don't do it with your production machine. I've just told you, you can change code on your production machine without an audit trail. There is no release. If you can do it, hackers can do it as well. So don't use it for production, use it for different remote machines. And this is actually everything I wanted to tell you for today. I'm going to wrap up. If you have any questions, I'll be over there. I will make space for the next speaker so he or she can prepare. Thank you for being here. I hope everybody learned something new, and enjoy the remainder of the conference. Bye-bye.